to the Spark Research YouTube channel. This is Dr. Vichandra, Assistant Professor in the Department of ECE. In this session, we are going to discuss about some questions from the course Electromagnetic Theory and Interference. Primarily, we will focus on the GATE 2025 that has already been asked in this year. So before going ahead, here, I am from SRM Institute of Science and Technology. So here you can see the NIRF ranking for this SRM IST, that is 14th, just above to the IIT Dhanbad, and so ranking is 14th. Okay, let's go ahead. So why are we talking about this course, that is EMT theory? This is very crucial because for the preparation of the gate, typically the questions may be asked in the range of 6 to 11 in normally. Now, what are the major topics that this EMT course includes? So these are the major topics: electrostatics and magnetostatics, where Gaussian law, Ampere's law, these are the important topics. Then Maxwell laws, all of you know this is the basic building block of your EMT theory. Then wave propagation in particularly rectangular waveguides and some uniform plane wave, these. Then the transmission line, like how you are going to uh, pass some signal through the transmission line, and the Smith chart is very much important. Then the antennas and waveguides, like antenna and the rectangular waveguides, so these are the important topics. Okay, so let's go ahead. So first of all, this GATE 2025 has been conducted by the IIT Roorkee, and so let's see the questions from this course EMT. So this question is from this EMT course primarily. This is I have taken a screenshot of this question. So this is the question has been asked from the transmission line theory, and as per provided answer key, as per provided by this IIT Roorkee only answer key, so your answer should be in the range of this 6.3 to 6.5. So we will see this question. Let's see the what is the question. Okay, so what is the question? Question is a 50 ohm lossless transmission line is terminated with a load of ZL is equal to this much. So a lossless transmission line is there. So first try to understand what is this lossless transmission line. So transmission line is only thing which is using to communicate the information. Since we are talking about the electrical, so voltage will propagate through this transmission line, right? Having this is lossless and having the resistance this one, so Z naught is given. Now there is a load, with the load having the impedance of this much. Why load is important? Because always if you wanted to deliver the some voltage, then who will collect? So your load will collect. So now your load impedance is there and Z naught is there, and transmission line already information is given that this is lossless. Now next you see, if the average incident power on this line is given 10 milliwatt, and then the average power delivered to the load. So now if you have the incident power, that is your voltage, incident power is your this much, the source power. Now you have to calculate the average delivered power, that's all. So how can we calculate it? So just now let's try to understand it in a better manner. This is your transmission line. Here is your source power. This is acts as a torch. Torch is it's emitting the incidenting the 10 milliwatt. And now here is a load. Load will collect the power. So how much will it collect? So load impedance is given. So basically how much voltage will delivered to the load, it will depends that how much voltage reflecting back, and incident to the reflecting, that is called the uh, voltage reflection coefficient, that is tau. If you remember, we have already discussed in theory class. So our objective is to find out the tau, that is voltage reflection coefficient. once we'll collect how much power reflected back, like suppose 3.6 milliwatt, then we can subtract 10 minus 3.6 is equal to 6.4. So this is a very simple way to find out. Now exactly how can we calculate? So let's see in the calculations in brief. So what I told you, our objective is to calculate the reflection coefficient, that is tau. If you remember, the formula is tau is equal to ZL minus ZO divided by ZL plus ZO. So ZL means load impedance is already given, ZO is also given both. So now it's very easy to calculate. So put the values and get the solutions. Here after putting value, just take the the magnitude of numerator and denominator, and finally you will get the tau, that is equal to 0.36. So since your 0.36, that is tau, means reflection coefficient, that is how much your power will delivered back, how much. So this is your out of 10, this is your 0.36, right? This is the, so remaining will be transmitted. So how much remaining? So P incident into 1 minus tau square put, and remaining is 6.4 milliwatt. So as per answer key provided through the IT key, your answer should lies in the range of 6.3 to 6.5, and exactly we got the value 6.4, right? So this is a 2 marks question. So that's all about this question, right? Now let's see the some one another question which has been asked in the same get 2025 through this IT key only. So now what is the question here? See, two resistors are connected in a circuit loop of area 5 meter square, right? Here are the two resistors and the area is given 5 meter square as shown in figure, and it is in the xy plane, okay? When a time varying magnetic flux with a flux this much is applied, now some flux is applied which is varying with respect to time through the z axis, means like in this axis perpendicular to this plane which is placed on this right. Now you have to calculate the magnitude of current in the loop, right? So suppose some source of the magnetic flux, like time varying magnetic flux is applied across this. Now you can ask, sir, why are they asking to calculate the current even if there is no voltage? Like see here in this circuit there are two resistor, resistor 1, resistor 2. Is there any voltage? Of course not. Then how is it possible that current will flow? So answer is very simple, because of this time varying magnetic flux, right? So because of, if you will keep this loop having the resistor in some time varying magnetic flux, then automatically there will be induced current. So we have to find out that induced current. So before finding the induced current, you know the resistance values, that is 2 plus 2 4, but we have to find out how much voltage will generate. So first let's find out the induced voltage, and already we know the resistance, so V by R we can calculate the current. So let's see. According to the answer key provided through the IT root key, answer should be in the range of 0.62 to 0.63, right? So before going to actual solutions, here is the pictorial view for the realistic view, like how is it working. So I hope all of you have used this induction at your home in your kitchen. So how your induction is working? So very simple, because of this coil, like induction coil is there, and whenever you are keeping in the changing magnetic field, then automatically current is flowing, and because of that heat is produced, and finally your water is warm or heated by the temperature something, right? So this is the application. So this is very real life application most of you had in your kitchen, right? So how is it working, your induction? So it's working based on this principle only. Okay, so how we'll find out? So here, so the suppose here the resistance, like already it is given in our question that two different resistance are given, and the current which will flow due to the magnetic field intensity, the magnetic flux, changing in magnetic flux, that has been given Bt is equal to 0.5 T Tesla. And so actually the once if we'll find out the induced voltage, then V by R will divide and we'll get it. So how we'll calculate the voltage, that is a challenging task. And finally your current will be the I is equal to 0.63 ampere. So let's dive into the details of the solutions. So here you can see what is our target. Target is to find out the induced EMF, that is voltage. So how we will find out the induced voltage? So induced voltage is nothing d psi by dt, right? So what is this d psi? So change in the magnetic flux, right? So first find out the flux. So flux is nothing, a magnetic field that is changing into the area, right? So it is already given bt is equal to 0.5 t, and area is also given, that is 5. So this will be 2.5 into t. Now voltage, that is emf, so d psi by dt. So put the values, 2.5 t divided by your dt. So t by the, the you will cancel out, you will get the final 2.5 volt. So this is the voltage which will be induced due to the magnetic flux in this circuit, right? So voltage is this, already you know the resistance, that is 2 plus 2 4. Now finally calculate the current. Current is equal to v by r, that is 2.5 by 4. So answer is 0.625. And as per answer key provided by the IT root key, answer should be lies in between 0.62 to 0.63. So you may leave with this answer, otherwise you can the approximate, and you can write the final answer 0.63. I hope you got the values, and this is the another way to solve exactly the find out the resistance, and then the find out the magnetic field flux intensity, that is phi t, and then using the Faraday's law, that is d psi by dt, you can calculate the voltage, and finally current, you can calculate voltage by resistance and same value. So this is the another process to calculate. So you can choose any one method, both are almost same, only little bit difference. Okay, so if you have any doubts, please drop your comments, and definitely I will come with another sessions which includes the questions from different years. I'm thinking to include some 5 or 10 years of questions for the gate solutions. Thank you for joining the sessions. If you have any query, if you have any doubts, please drop your comments. I will definitely consider your comments. Thank you for joining.